So we'll start a new lesson in circle chord properties. So we know, so what is a circle? We can simply define like this. So we define a circle whose points are the constant distance from a fixed point. So what is a fixed point? We call it center. Or that is center O. So the distance from O to any point in the circle is its radius. So radius we represent by r. So what is radius? It's a line joining the center to any point in the circle is radius. So what is a chord? Chord is a line segment joining any 2 points on the circle. Chord is simply a line connecting 2 points in the circle. This is a chord. So if we join these 2 points, this is a chord. Sorry, this no. So let us represent it. So AB is a chord. Similarly, AC is a chord. The starting 2 points is cutting this line AC if it is extended, cutting the circle at 2 points. So what are the theory what we have seen earlier? Equal chords of a circle are equidistant from the center. So how we prove this? So let us take an example. So let us take two chords. Equal chords of a circle are equidistant from the center. What's the meaning of center is O. Let us take two chords AB and CD. So what is given? AB is equal to CD. So to prove that these two chords are equidistant from the center. So equidistance means is the perpendicular distance from O. That is the equidistance. This O. So O we draw perpendicular. That is the distance from center O to the chord CD. So let us take this point as E. This point as F. So okay, we'll join these two OC and D. Similarly, we'll join BO and OA. So let us so if we consider the two triangles, ABO and CDO. So they are congruent. How? AB is equal to CD. So all other components, BO, OC, BO, these two are equal to radius. So these two triangles are congruent. if we draw a perpendicular line to both these triangles, what about these two triangles? It is perpendicular, one side is common, the other side is radius. So these two triangles are rather congruent. So what about this OE? It is perpendicular bisector for line AB. Similarly, what about OF? It is perpendicular bisector for line CD. And AB is equal to CD, perpendicular bisector bisects this line also into two, this line also into two. So OE is equal to OF. That we can prove. In circle, it is very easy to prove. So what we have to look, if chords are equal, it perpendicular distance is equal, radius is common. So wherever perpendicular is there, we can take. If these two, any of the combination of any of this will prove that require. It will give enough clues. Very easy to prove in circles. So we'll work out some problems to understand the basic concepts more. Draw a circle of radius 3.5 and construct a chord of 6 meters in it. Find the distance between the center and the chord. So we will just draw some diagrams. Students can actually try with actual measurements. We are not trying here with actual measurements. So let us take this is radius 3.5. A chord of length 6. He says, okay, let us take this chord is 6. Find the distance. Now let us take its O is the center. Let us draw a simple diagram. So what's given? This radius is 3.5. This radius is 3.5. The chord length of the chord. Let us take this as AB. AB is equal to 6 centimeters. Distance between the center O and chord AB means it's the perpendicular distance. This perpendicular divides the line AB into two portions. So we have to find OC. So AB is 6. So BC is 3. So we'll take like this is 3, this is 3. We know the radius is 3.5. Then we can find the perpendicular distance. OC is equal to root of OB square 3.5 square minus CB square 3 square. So what is 3.5 square? 3.5 multiplied by 3.5. Oh, sorry, correct. So it is 3.5 square is 12.25 minus 3 square is 9. So difference is 3.25 root of. So root of 3.25. So this is a square minus b square. We can take a, so we can use the formula. It is equal to a plus b into a minus b. A plus b is 6.5. A minus b is 0.5. If we multiply, it is 3.2. So root 3.2 is the answer. If we can find a table, we can find we can find out the roots. Actual root we can find out. Okay, we try to find out the root. 1 point. So we put 1. So it's root of 3.25. We take a root. It's it's approximately it's 1.8. You can take. So you want to check. You try 1.8 multiply by 1.8. It is 3.24. It is 1.8 approximately. Okay. Next, we will see something. What is the meaning of congruent circle? Concentric circle. What is the difference between these two? Concentric, congruent. So congruent is the usual meaning. So you have got one circle here, other circle here, the same radius. These two circles are congruent. So there's another circle here, the same radius. Radius must be same. Then the circles are, what would be a concentric circle? So you have got a circle. Okay. So you got another circle inside. And with the same center. Center is same. That means concentric. The two circles with the one inside the other with the same common center. So concentric means center same. So congruent means it is equal radius. So we'll try. So draw two concentric circles of radius 2 and 3. So how we draw? Similar to 2. We draw a circle of radius 3 center with the same point as radius as center. We draw another circle. So this is 3, outer circle is 3, inner circle is 2 radius. This is not a scale. You please try to draw as per scale. You draw the diagram as per scale and practice. So we'll do some more problems. Draw two circles of same radius 3 centimeters with the distance between the centers equal to 8 centimeters. So we'll be doing more problems in. So draw two circles of radii. So let us take two circles. We have to draw a circle. So with the center, now draw a line of 8 centimeters. We'll have another circle. This with the center, you draw a circle of, so here radius is 3, here radius is 3. The distance between O, and let us take this as O dash. O dash is equal to 8 centimeters. So we have to draw a straight line. With the compass, we have to cut from O dash. We have to cut here. Find out the center. From the center, we have to draw a circle of radius 3. O dash is equal to 8 centimeters given. So students should actually draw as per the measurement and practice, so that after drawing they can check with the scale whether the measurements are correct. Both radius, you have to mark the center clearly. So next problem. Draw a circle of radius 4 centimeters and construct a chord of 6 centimeters in length. From the chord, draw two angles in major segment and the two angles in the minor segment. Measure and check. This is a little big problem. No? We'll just draw the diagram. Students should try so that they will remember what they are trying to tell in this problem. Draw a circle of, okay, this is not according to scale. I will just simply draw 4 centimeters and construct a chord of 6 centimeters. How you construct the chord? You take any point, how you construct a chord of AB? You take any point, A, with the compass you draw, AB is equal to chord, length of the chord is 6 centimeters. You cut the circle, you know this point, now you will join A and B. From the chord, draw two angles in major segment and two angles in minor segment. So what is telling? You take some point, okay? Some point C, some point D. So you now draw in AC and BC. Similarly, you join AD and BD. Now you check these two angles. So what it says, draw a circle of radius 4 centimeters, construct a chord of 6 centimeters in length. From the chord, draw two angles in major. Simply draw something, and two angles in minor. This is major segment. This is major segment. Oh, okay, sorry. So this is a major segment. This. What about this is a minor segment. A. So we'll draw two. We'll take 2 points and draw another two lines. No, like this. Oh, sorry. This one. From B, you take some other point. You join these two. Now measure these two angles. So what do you expect? So you will notice angle C is equal to angle D, and of course this AB, you take this point as E, the other point as F. Angle E is equal to angle F. You'll find this. So the property of the circle is any chord makes equal angle with any point in the circle above one particular angle, below one particular angle. The sum of C plus, you check what is C plus C, that should be 180. Please check by actual drawing, measurement. You have to make a measurement and check. Suppose let us take for example, this angle C and D is equal to 60. The other angle will be 120. Suppose if the angle is 70, this angle will be 1, like that. Total will be 180 degrees. To be very precise, if you join CD, you observe the properties of the cards. Okay. So an extension of it, what will happen if it is a diameter? Suppose we are having a circle instead of chord. It is passing through center O. So what about this angle? If you observe, angle is 90 degree. Any point on the circle. So this is 90 degree. And you'll notice any point, in this case, even below. So any point in the circle is 90 degree. Now we are given example You can do the problem 6 yourself. In case of diameter, the angle is 90 degrees. Okay, you please draw the diagram and check. Thank you.